Welcome back, everyone. Here we are with another episode of the Midnight Sessions. Let's get started. Perfect. So now let's see this other blog about the Midnight Foundation and Google Cloud. It just dropped on September 30th. So we're gonna take a look at this blog. For those that want to take a closer look, you can find this blog on the Midnight documentation under blogs. You can find this one, and you have here all the details. But for this session, what we're gonna do, as always, I made a summary and I put it here. We're gonna read it together, and then I'm gonna add some extra context and discuss some specific points that I think it's gonna add a lot of value for you guys to understand and see how things get connected. So let's read it together. Midnight Foundation and Google Cloud collaboration. The Midnight Foundation announced a strategic collaboration with Google Cloud to enhance enterprise-grade security, infrastructure, and developer tools for the Midnight blockchain. The partnership aims to advance privacy-enhancing and zero-knowledge technologies as foundational infrastructure for next-generation digital system. So Google and Midnight are working together to create a better tooling and infrastructure regarding privacy technology. Huge news. Some key points. The purpose of this partnership: to solve the issue of public blockchains exposing transaction data, enabling privacy-compliant applications for finance, government, and healthcare. Some use cases that we can use Midnight right now. Financial institutions can perform private trading and cross-border payments with compliance. Governments can issue verifiable credentials without exposing citizen data. Healthcare can share research insights while protecting patient privacy. Some enterprise infrastructure topics. Google Cloud will run a validator nodes and operate critical network services for Midnight. So this is huge, this point here. So what this means is that Midnight is going to be a Midnight validator. And not only that, it's going to be a SPO, a Cardano validator as well. Why? Because for anybody to be a Midnight validator, you have to be a Cardano validator as well. So huge news for Midnight, huge news for Cardano, but not just these two blockchains, other blockchains in the future. Remembering that Midnight, it runs through partner chains, and we're going to have Minitor where other blockchains are going to add to this mesh. So Google Cloud eventually could run these other nodes as well. So really huge news. Mandiant, Google Cloud Division, will provide threat monitoring and incident response for high security assurance. So they're gonna give all the security that they are really good at while running these nodes. Midnight Zero-Knowledge Proof Tech will integrate Google Cloud confidential computing for protected data environments. Okay, this might have sound a little bit confusing, but it's a huge topic and it's gonna add a lot of value for developers working with private technology. So what it means, Google Cloud confidential computing. So regarding the privacy tech, we have different technologies to accomplish that. One of that is zero knowledge that we already know, we have talked about for developing with Midnight smart contracts. Because we have this on-chain part and we have the off-chain part, right? And we calculate this proof using off-chain data to send some commitment, some attestation to the on-chain part using zero knowledge. But there is another huge world as well that we can do on the off-chain part, right? And there's technologies as TEE, Trusted Execution Environment, where you can compute certain function or for example, training a AI based on certain data, and then nobody knows that data except the TE, which is pretty much an enclave based on hardware. So Google Cloud, they have that service and they are really good at. So the idea is join forces and you're gonna have this zero knowledge with blockchain plus TE, everything within a kind of an SDK that developers can use to develop these privacy enhanced applications. So really a huge topic. I'm gonna give you an example of how can we mix this TEE with zero knowledge proof. So let's say you have artificial intelligence, right? That you want to compute some weights based on patients' data. But hospitals, they cannot share the data because it's private. So using TE, you're gonna be able to calculate those weights of the artificial intelligence based on those data privately, and then using zero knowledge, you can prove that you have done certain things on these TE enclaves, and then you can do something on the blockchain. So see how you can you can do some really nice healthcare medical records data processing kind of applications with these combination of technologies. So this really unlocks a lot of use cases, and it's gonna really nice to see in the future. And as developers, we're gonna have the tools and infra for doing that. Okay, ecosystem growth. Developers building on Midnight can apply to the Google for Startups Web3 program, gaining up to $200,000 in Google Cloud credits, AI resources, mentorship, and training. Huge, right? I was mentioning, right? The TE kind of use cases, all this infra that we have available for us, and now we can gain these $200,000 for developing applications using that technology. Really huge news. The goal is to expand community tools and attract new developers to build privacy-focused decentralized applications. So some extra comments based from Midnight and Google. The future of enterprise applications requires both transparency and privacy, said Richard Whitman, head of Web3 strategy at Google Cloud. And Fahmi Sayed, president of Midnight Foundation, emphasized that privacy will shift from a barrier to a competitive advantage for a scalable, compliant, and secure system. So really nice to see how blockchain technology it's now giving solution to some complex topics that it was not possible before in the traditional systems. Okay, excellent. Let's now take a look at this blog about the upcoming Midnight Summit Hackathon. Really interesting blog. We're gonna take a look at that. Again, for those that want to take a closer look, this material is available in the Midnight website under blogs. You can enter here blogs and find this title, and you're gonna have all this information. But as usual, I made a summary for you guys where we're gonna read it together and we're gonna discuss some points, and I'm gonna add some extra context. Perfect. So this is the summary. Let's read it together. Everything you need to know for the 2025 Midnight Summit Hackathon. This document, so we're gonna first give a summary of all the topics that we're gonna discuss, and then we're gonna see the details. This document serves as the official guide and central source of truth for the Midnight Summit Hackathon. All participants should use it as the main reference for rules, schedules, and track details. The information will be updated as necessary, so please check back regularly for the latest version. It includes key dates, submissions rules, price structures, technical tracks, and judging criteria. So this was last updated on October 24th. I think it's the latest version since we already had some introduction of the rules during some meetings, and people have started working on the projects. But nevertheless, just keep a close look at the blog in case something changes. Okay, outline of the guides. So let's see what are the topics that we're gonna discuss. Key information and useful links. A high-level summary of important dates, deadlines, and resources. What else? Official rules and submission guidelines. All teams must adhere to these rules to be eligible for prizes. Hackathon tracks, descriptions, technical prompts, and example ideas for each of the 4 tracks. So we're going to have 4 tracks. Prizes, breakdown of what teams are competing for, including cash and the 8-week build club. Judging rubric, detailed description of how projects will be scored. And forthcoming, further details will be added, so check back, right? So this is a summary of a blog post that might get updated, but I think this one could be one of the latest versions. Okay, let's see the actual information. Key information and useful links. Hackathon dates. So the hackathon is going to take place during November 17th, 18th, 19th of this year. Where? Location, London, UK. Remote participation allowed, but at least one member must pitch in person at the venue, right? So this is nice. We want to see that groups can have up to 5 members, but at least one of them, it has to be present during the pitch in London during 19th of November, right? The other 4 members, they can participate without having to be within the UK or at the venue. Initial code submission, November 18th. Open source GitHub repository for preliminary preview, right? So it's going to be a GitHub repo, open source, and you're going to present it on November 18th. And the final submission deadline, November 19th. So you present it on the 18th, the link, but then you can still add commits all the way until you do the pitch. Judging and winners announcement, November 19th. Core rules summary. So team size, as we mentioned before, is going to be up to 5 members. Accommodation. Venue will not stay open overnight. Hacking may continue at hotel. So this is important. We have seen during other hackathons that there are some teams that set up some tents on the corridors or at the corners or somewhere to sleep like 2-3 hours and then keep on coding. But this time, this is not going to be allowed. Developers are going to have to go back to the hotel and they can continue coding back at the hotel. Code submission. Must submit by November 18th, but commits may continue until November 19th. Okay, what else? Net new projects only. No prior hackathon work or contracted code allowed. So this is important, right? There is right now hackathoners, they have a lot of information that they can take a look at, but none of these prior work it's allowed to present. You're gonna have to change it in some way, new ideas, new implementations. And for those doing code that it's being contracted by the foundation, you're not gonna be allowed to use that code. Okay, useful links and resources. Developer Hub, technical documentation, support forum, hackathon Discord channel. There is a channel that is called Summit Hacker. Past project showcases and silly quest list. So you see now all new developers entering the ecosystem or those that want to participate during hackathons, they have plenty of sources and materials available to actually learn how to do those applications. Okay, what else? Official rules and submission guidelines. Teams from 1 to 5 members. Location and remote work. Remote is allowed, but one team member must be physically present in London, right? So you can have a group of five members, one in South America, Europe, Asia, outside UK, and also within UK, but one member of that group, they have to be present physically during the pitch at the venue. Okay, venue access, no overnight access. off-site development allowed, right? As we mentioned. What else? Project eligibility. All work must be new for this event. No work under contract. Submissions. 1 project per track. A team may submit multiple projects but can only win 1 track. So if your team wants to present several projects for different tracks, we're gonna have 4 tracks, your chances are going to increase. But if you win 1 track, then you're not going to be able to win the others, right? What else? Pitching and selection. Initial repository required by November 18th, and code may continue until November 19th, final deadline. Of course, during the 18th, the judges, they might start taking a look at the code, but still you can update new commits until November 19th. During your final pitch, you can say, okay, we have updated something, and this can be included during the judgment of the judges. Okay, top 4 projects per track, 16 total, will be selected for final pitch. So there's going to be a lot of projects presenting code through GitHub links, and only 16 of those projects are going to be selected, and those that are selected are going to be able to pitch the projects during the 19th. So really nice to see those 16 projects. It's going to be really, really awesome, and you're going to see just in a minute what are going to be the tracks. Hackathon tracks. There are 4 tracks, each focus on a different high-impact problem, leveraging Midnight's programmable privacy. Track number 1, AI, privacy-preserving intelligence. Build applications that enable inference and decision-making without exposing raw data. Examples: private AI audit, confidential inference, API, AI reputation layer. Track number 2, healthcare, confidential care coordination. Build privacy-preserving data exchange solutions in healthcare. Examples: consent ledger, clinical trial privacy vault, and insurance claim resolver. Track number 3, governance and identity, trust without exposure. Build systems for voting, identity, and governance that are private but verifiable. Examples: private DAOs, voting, reputation passport, civic registry. And track number 4, finance, compliant privacy for real economy. Build compliant DeFi or fintech primitives with user privacy in mind. Examples: privacy payment rails, CKYC lending pool, and escrow with disclosure. So these tracks, I consider that they are really clever, they are really amazing, and are really high impact. You can see from the AI, healthcare, there's a lot of inference kind of idea, and we were talking on the previous blog about privacy on the off-chain part with Google Cloud, with TEE technology. So you can see how different parts, how different technology regarding privacy can get together and build hybrid applications and solve these kind of complex issues as AI and healthcare. Excellent. Prizes and build club. Total 5 teams will be selected. The top overall project is gonna win $15,000. This is a really juicy pot. Track winners up to 3, $2,500 each, and the runner-up, 1 winner, $2,500 as well, in the same track as the top overall, right? Okay, all 5 winning teams join the Build Club, an 8-week part-time educational program. This is really nice. You're gonna be prepared, you're gonna be trained for what's coming. Build Club includes, so let's see what is this Build Club. Weekly guidance sessions on business, technical, and go-to-market strategy. Really important. Product is not only code. There is a lot more on that, like product, business development, marketing. Access to tools, resources valued at $100,000, and the opportunity to pitch to Midnight's investor network and join the Midnight Accelerator at the end. Huge. Okay, judging rubric summary. So projects will be scored in these domains. There's gonna be 6 ways to evaluate teams. The first one, product and vision, 20%. Problem definition, vision, use of Midnight's core capabilities. Another way of evaluation, engineering and implementation. This one is gonna be weight 20%. Technical soundness, architecture, reliability, Midnight tech usage. Another one, user experience and design. This is going to be weight 15%. Interface, intuitiveness, end-to-end experience, and professional presentation. Another one, quality assurance and reliability. This is going to be weight 15%. Testing, stability, version control, readiness. Another one, communication and advocacy, 15%. Clarity of purpose, presentation, community engagement, and education. And lastly, business development and viability, 15%. Market understanding, adoption path, scalability, alignment with Midnight goals. So this judging rubric summary, it's really interesting because you can see that the code itself is just a small part of the evaluation process. And actually for your product and project to be successful. If you can see here, the engineering and implementation is just 20%, and the quality assurance, which is testing, which is also important, is another 15%, which I consider kind of like the core implementation of your project. So it's 35%. The other rest, which is 65%, there's other topics. For example, product and vision, right? You have a problem, the solution that you're trying to include, it actually solves that problem. User experience and design, you can have a really innovative solution, but if the user doesn't understand it, they're not going to use it. Communication and advocacy, if you don't know how to express your idea, you don't know how to really click with your user, they're not going to use your product as well. And the other one, it's business development, right? So everything comes down at the end with businesses, marketing, and viability. So if you don't know how to manage these things, even though you have an amazing project, it's not gonna be successful. So this is really interesting, and it's gonna make it clear for every builder working in Midnight that to have a successful project, you're gonna have to follow this procedure. Perfect. So I really look forward to see this hackathon during London. Okay, perfect. Let's continue learning how to write smart contracts and compile it and test it. So this is part 3 of the bulletin board contract. For those that haven't watched the first 2 episodes, the first 2 parts of this bulletin board contract series, I recommend for you to watch them first, right? This is the 3rd part. The last 2 episodes, we started with part 1 and part 2. So go ahead and watch them before you continue here. Okay, so now that you've watched part 1 and part 2, this is the part 3. So we already know what this bulletin board contract is about. We know how it's structured, what we want to accomplish, and we have already compiled it, right? The idea now is to understand this testing framework, so we know that the logic part of our contract, it's okay. It's following the rules that we want. Perfect. So for that, we're gonna go deeper into this manage bulletin board folder, which is the output of the compiler, and this other folder here, which is called test, where all the testing framework it's written in this folder. Okay. First of all, I wanted to show you a diagram so you can better understand how things are connected and what parts we are actually gonna test. So we have this diagram. This is something that we have already watched and learned during the last episodes, but we're gonna give a refresh here in the context of the testing of a contract. So when we compile a contract, we have these two different outputs. We have a CKIRs with the intermediate representation of the zero knowledge, and we have the prover keys and verifier keys of each of the circuits. Additionally, we have this contract.js, which we have an implementation in JavaScript plus the types. So let's see here in our contract that we have those outputs. So after compilation, we get this file, right? Managed bulletin board. And we have the compiler. This is just a JSON with the structure of our contract. We're not gonna need this right now. In the future, when we have contract to contract feature, we might use this folder here. So let's focus on these other three. We have the contract. So we have the index CJS, which is the JavaScript implementation of our contract. So this is one of the outputs we just mentioned. And we have this index DCTS. This is the structure and the types of the JavaScript implementation. And additionally, we have the keys. So for each circuit, post and takedown, we have the verifier and the prover keys. And the CKIRs. So this is the intermediate representation of each of those circuits. So we see here, we have this language here that they have the instructions that represents the logic, the circuit of post. And we have the same one for takedown. Excellent. So we have already confirmed that we have the outputs that we expect after compilation. What we need to understand now is how we're going to use this JavaScript implementation during the testing of our code. So for that, it is important for you to remember that what we are doing here is using this contract JavaScript plus some additional inputs, which are the witnesses that's already embedded within the logic of the contract.js because we put it during the contract implementation, plus some inputs of the DApp. In this case, we're not going to have a DApp. It's just a simulation that we're going to represent some user inputs and this impact virtual machine. So this is really important, right? We're going to simulate the actions of our contract as it was running in the node. So in the node, we have this impact virtual machine. So if the logic of our contract passes here, if the same conditions keeps the same, that logic should pass here in the node as well, since we are using the same virtual machine. Excellent. The other thing is that you see here that we are going to compare the outputs of this contract.js, since we only want the logic part. So based on some inputs, we're going to have some outputs, and we can compare those outputs based on the expected outputs that we want. So this is the logic part of the unit test. We are not going to need these prover keys and to generate this proof and interact with the node. This would be the second phase of a testing, which I call integration test, because you're going to use some providers. For example, the node and the proof server. For this first part, which is phase 1 testing, we are going to just test the logic part, right? This part here. Excellent. Now that we have that in context, I can continue with the implementation of the testing framework. So let's open this folder here, test. And we can see here that we have a simulator. We have some types. In this case, we are not using any types. we have some utils, helper functions, and then we have the test itself. So first, let's see the simulator implementation. Okay, so we have all this code. I can tell you right now that it's not necessary for you to learn by heart the implementation of this code, because it's the majority of this code, it's boilerplate. In the future, you're just gonna copy paste this code here and just change some parts to actually kind of adequate this framework to your specific contract. So what I want to show you, actually, it's kind of the macro of this framework and what are the important parts and some types and variables that is gonna make you better understand this framework. Okay, first thing, we can see here that we have a class called Bulletin Board Simulator, and we have a property of contract. So this contract, where is it coming from? If we go back to the JavaScript implementation after compilation of our contract, we can see here that we have a class of contract, and we have here all the implementation. We don't need to see the implementation itself. What we need to know is what are the functions, property, methods that we have available. For that, it's better to go to this index DCTS, where we have the types and the structure of those classes and functions. And if we see here in the declared class contract, we can see here that we have witnesses, we have access to circuits, we have access to impure circuits, and we have access to a constructor and an initial state. Perfect. So we can see here that we are using this contract to have a property of contract. Of course, we need to have an instance of that contract. So here we are just initializing a new instance, new contract, and passing the private state. Perfect. Another thing, so you can better understand this part here, I'm just gonna go straight to a circuit implementation. For example, here at the bottom, we can see here, for example, the circuit post. In this post, we are passing, we are using, the instance of the contract and then calling the impure circuits. Remembering that in the contract, we have access to the impure circuits. And we actually have two of them, right? Post and takedown. Here we have post and takedown. Excellent. So we are calling impure circuits, we are calling the post, and then we are passing this circuit context. Okay, what is circuit context? Okay, as I mentioned before, it's really better to go to this index DCTS to better understand the types and the structure of the function circuits. So if we go here to the top circuits, we can see here the implementations of post and takedown. And we can see here that, for example, in post, we have this context, we have the new message, and as an output, we have this circuit result. Let's compare that with the actual implementation of our code. In the bulletin board, for post, what we have? As arguments, we have just new message. And as output, we have an empty object. So, new message, empty object. In this case, in the post, what I have is the message, right? But also I have this circuit context. And I can see here, I have context, the new message, and the output. So what is this context about? So we can see here that the type of this context has compact runtime circuit context, and the output, besides this empty object, which is the expected output, it's wrapped by these circuit results. So we have three questions now. What is circuit results? What is circuit context? And what is this compact runtime? So compact runtime, you should already know the answer, but if not, don't worry. Let's take a look here. I mentioned to you, right, that for testing the contract, we want to use the witness, some inputs, and the impact virtual machine. So this impact virtual machine, it's the compact runtime that we're going to use. to actually have some properties, methods, types, and the runtime itself of this virtual machine. Okay, so this compact runtime, we are getting that from the Midnight Network compact runtime. And then we are having circuit context and circuit results, all coming from this compact runtime. Okay, how is it structured that type? Well, let's go to the docs. So this is our best good friend, the docs. And we can see here, I'm gonna close this so you can better find yourself if it's the first time that you are opening the docs. I'm just gonna close all this. So this is the docs. We've been taking a look at this compact language before, right? To actually write the compact code. But now that we have compiled it, we're gonna need this runtime. Where we can find that runtime? Under API documentations, we have this compact runtime API, and that's something that we're gonna need, right, for the logic testing. If we open the compact runtime, we have classes, enumerations, functions, globals, interfaces, type analysis. What we are trying to look right now, it's what is circuit context and what is the circuit results that are types that we're gonna need to actually construct those circuits. So if we go to, for example, interfaces, we can see here that we have circuit context. Okay, let's click on that. So circuit context, we have 4 properties. One, it's the current private state. This is the current private state for the contract. Okay. Then we have current cswap local state. So this is a current cswap local state, tracks inputs and outputs produced during circuit execution. This is nice, right? So we are now seeing that this context, it's associated with some state at the beginning of the execution of the circuit and then after the execution of the circuit. We have original state. This is the original contract state the circuit call was started at. Okay, so these 3 states, we should be familiar by now where they are positioned within the Midnight tech stack. So let's go back to the diagram. We have already taken a look at that, but we're gonna refresh here. So this is kind of the 3 states that we managed, right? And we talk about right now during the testing framework. We have the private state, we have the smart contract state, which is the public state, and then we have the cswap public state, which is pretty much structured by these Merkle tree commitments and these nullifiers that is going to make sure that doesn't happen any double spending. Okay, so we are representing these 3 states in here. In here, current private state, current cswap local state, and original state. And then we have this other transaction context of type query context. So what is this type? I don't see here query context. But if I go here under classes, I can see here that we have a class named query context. Okay, let's open that. We can see here that we have a constructor, new query context, to build a new class of query context. We're going to use that in a bit. But I want to see the properties of this class. We have address, the address of the contract. We have block, the block level information accessible to the contract. Commitment indices, the commitment indices map accessible to the contract. Okay, this is something really important. Going back here to the diagram, we can see here that we have contract, but some of this contract, it's associated to some of these commitments, right? So it's kind of like, what are the UTXOs commitments that these contracts own? Okay, we have commitment indices, we have effects, and we have state. The state is the current contract state retained in the context. So it's the one that it's being updated after the execution. And these effects, what are effects? So if we see here that it has type effects. So let's go here under types, and we can see here that we have effects. So let's open that, and we can see here effects are the contract external effects of a transcript. So whenever you execute a circuit, there's some effects that are going to take place. What are those? Claim contract calls, claim nullifiers, claim receives, claim spends, and mints. So pretty much if you have, during the execution of the circuit, you mint a token, you spend a token, you receive a token. If you spend, you have to actually claim a nullifier, right? Remember here, we have this Merkle tree and nullifiers. This is a way you avoid double spending. And then we have claim contract call. This is going to be used when we have contract to contract communications feature, but right now we're not going to use it, right? So these are the effects that we have after the execution of a circuit. So, well, really nice. We know now what are the types that we need to actually create a circuit. So now that we know the types, the next question would be, okay, Eric, how do I create a circuit context? Well, that's easy, and we want to use that method that I just showed you. So here, we want to create this circuit context, right? Because if you see here down here at the bottom, when I call a post, I'm going to pass this circuit context. When I call the takedown, I'm going to pass the circuit context. So I need a circuit context. So let's create one. So circuit context, we're going to have this current private state. This is going to be the output of this initial state. So the first thing, we initialize the contract, and now we're going to initialize the state. It's kind of deploying the contract. Remembering that here we have in the class contract, in the class contract, we have this initial state method. So we are going to call initial state, and we are going to pass our secret key that we passed during deployment, and the coin public key of the user number one, the one who is deploying this contract. Okay, after this initial state, what I'm going to get is the three states: the CSwap local state, the contract state, and the private state. So for the circuit context, we have 3 out of 4 variables. We have the current private state, the current CSwap, and the original state, which is the current contract. But we still need this query context. Well, we have this method, new query context, and we're going to pass the data of our contract plus a mock contract address. How do I get a mock contract address? Well, we have this function here, sample contract address from the Midnight libraries. Excellent. So in that way, we already have the circuit context. So now what I'm doing here is that the circuit context is kind of what a circuit needs and what is the output of a circuit. So this is kind of the output that I need to analyze after the execution of a circuit. But also we need some private state. So that's why I have as another property this user private state as a record of a string bulletin board. So I can have different users. I'm creating this framework so we can have different users with coin public keys, but also different users with different private data information. Excellent. So if you see here down at the bottom, for example, let's take a look at one of the circuits implementation, post. What I'm doing is I'm calling the instance of a contract. I'm calling impure circuits. I'm going to call post, and then I'm passing the circuit context, and then I'm passing one specific sender. I can use different circuits. I can use different users. And then the result, which is circuit results, I'm going to pass it to this function. One thing that I forgot to show you guys, what is this circuit results, right? We mentioned here that in post, we have these circuit results. So let's take a look how this circuit result is structured. So let's go back to the docs here, and we saw before circuit context. Now let's take a look at circuit results. Circuit results is a structure in context, circuit context. So the circuit context at the beginning, it was of type circuit context. And the circuit results, one of the properties of the result is the circuit context, but updated after the execution of the circuit, plus other two properties, proof data and result. This result here at the bottom represents the results that we say here at the end of our circuits. In the case of pause, it's an empty object, and in the case of takedown, it's an opaque string, right? So this is the result. What is the proof data? Proof data, it's the data that we're gonna need to actually create the proof. But since we're just testing the phase one, we are not gonna need that one, right? So this proof data, it's something that we're gonna need here to actually, using the CKIRs plus the proof data, we're gonna, along with the proof server, we're gonna be able to create the proof, right? But we are not gonna use that output since we are not testing the integration part, right? This is called the integration testing, that it actually uses providers. In this case, we're just using the logic part. Excellent. So let's go back to the code. So you can see here that I was showing you that in the simulator, I'm passing the circuit results to this function update state and get ledger. And what I'm doing here is grabbing the context of the results, right? I show you that result has three properties: the context, the proof data, and the result. So we want the context, the updated context after the execution of the circuit. And what I'm doing is updating the circuit context property of the class of the simulator with the updated context. So normally this would be at the node, right? But in this case, I'm simulating that within memory in JavaScript in the node. And also I'm updating the private information. So I'm updating the ledger as a memory and the private information. And during the and in implementation, I'm simulating the pause circuit, I'm simulating the takedown circuit, and the public key, which is a pure circuit. Perfect. So with this simulator, I'm connecting all these different features to actually create the execution of our circuit. What we need to do now is having that simulator class to actually create different logic for those outputs that we want to test the logic from, right? So let's take a look here. For that, we have this other file here called bulletinboard.test.ts. So let's open that file. And we can see here that we are doing a lot of tests. We're using VTest for doing this test, right? So we have 8 different tests. So let's see what are those and how they are structured. So in this part, we are creating some inputs representing the user, right? Connecting back to the diagram, represent this part, creating some inputs. And I'm using some helper functions from the utils folder, right? Utils. So here I'm just getting some data with the types that I need to, right? This index DCTS is really important because here it says what are the types that I need for my circuits to actually function. I don't have a runtime error. And so I'm using that utils helper functions for that. Perfect. So now I'm creating this create simulator. So I'm using my class and running the method deploy contract, which actually initializes and create an instance of the simulator. And I'm just initializing with user number 2 and I return the simulator. So now I'm going to start creating the different tests. The first one, I just want to deploy and test the ledger variables. So what I'm doing is create a simulator, which is kind of simulating the deployment, and then assigning user number 1, and then I'm comparing the different ledger states variables with something with values that I want. For example, instance, after deployment, I want to be equal to 1. Message, I don't want to be nothing. The message value empty, which is the when we deploy the constructor, we want the message to have nothing, and the state to be vacant, right? So that's why in this test, what I'm saying, I want this message to be false, I mean doesn't have anything, and this message value to be empty. So if it happens to have those values, the test is gonna pass. Otherwise, it's gonna fail. So we are testing the logic, the expected outcomes. For the poster, equal, right? We want this to be a uint A8 array 32, which is empty, no values, which represent the bytes 32, right? Then the state, I want it to be vacant, and then I'm just comparing the private state. Perfect. If that passes, it means that our logic is okay during deployment. But now let's test other cases. Now in this case, I'm doing the same procedure. I'm creating the simulator, getting the private state, but now you see here that I'm executing a circuit, which is the post. I'm passing this message, right? It could be whatever message, but I'm passing this one here. And I'm passing the message, and then I'm comparing the state of the ledger, in this case in the memory, after executing this circuit. So for the case of instance, now I want to be 1. The message, I want to have something. The value of the message, it's that message that I pass. And the poster, I want it to be the public key. And the state, I want to be occupied. If some of these values doesn't correspond to these ones that I passed, it means that the logic of my contract is not that one that I thought it was. So that's why it is important to write this unit test. Okay, let's see here another test. We are doing the same procedure, right? Initializing the contract, and now I'm executing 2 circuits. I'm posting as a user 1, and I'm taking down the post as a user 1. It should pass, and then I'm comparing the ledger values, to have this state. Since I executed 2 circuits, I want instance to have the value 2, the message to be empty with empty string, and then the poster to be the initial public key and the state equal to vacant. If it passes and it has those values, it means the logic that I implemented, it's okay. Let's see another one. As a user 1, I want to post. As a user 1, I want to take down. As a user 1, I want to post again the message, and this should pass. And then the state should have these values here. If this corresponds to the logic that I wanted to implement, then it means that the contract was well implemented. So it is important to have here the correct values, right, that you want. For example, I want here 2n. If your contract logic represents something else, and the output of this, after running these circuits, you want this instance to have 3 for n, you're gonna have to write here for n, right? Everything's gonna depend on your logic. But what I want after executing those circuits, it's instance to have 2n. Excellent. What else? Let's see here another test. We are calling post as user 1, and then I'm taking down as user 1, but as another caller, another user. And this one, I want it to fail. Why? Because you remember the logic of our contract. The user that posts something is the one that is going to take down something. If somebody else tries to take down that post, it's going to fail. But because only the user that posts, that run the post circuit is going to be able to run the takedown circuit. So that's why I'm expecting this to fail. And then I'm taking down again with as a user 1. And then comparing the state. What else? Here I'm posting as user 1, and then I'm posting again as user 1. And the second circuit, I want it to fail, to throw an error. Why? Because the logic that it was written in the bulletin board, I consider that only one user can post at a time, and before somebody else wants to post, the board has to be empty. So if I post something, I cannot post something again, right? So in this case, I want this circuit to fail. So when I run the test, if it fails, it means it passes the logic. Okay, I have here another test. I'm running pause as user 1 and then pause as user 2. And I want it to fail as well. And lastly, this other construct, I'm posting as user 1 and then I want to take it down as user 2. Again, if I'm taking down something that I didn't post it at the beginning, I'm not allowed to. Only the user that posts is the one that can take it down. So here in this case, the other user 2, want to take down something that user 1 actually posted. So I want that to fail as well. So after running all these tests, what I need to do now is just run the test. npm run test. And I can see here that it ran all those 8 tests that we just saw, and all of these 8 tests passed, which means that our contract, it was written okay, the syntax is passed because it compiled, it was well optimized by comparing the sizes of the circuits, and the logic corresponds to our intention. Perfectly, we have learned so far how to do the logic part and the unit test. Okay, perfect. Now regarding questions and answers, somebody just asked me something about the Scavenger Mine. So decided to include it as a question and answer for you all. So we're gonna read this blog from the Midnight Foundation about the Scavenger Mine will soon open to all, right? So I made a summary so we can discuss about it, and it's open for everybody. So it's we're gonna have really nice information here. So okay, Scavenger Mine opening soon for everyone. Launch October 29th. Platform, you just need a web browser that could be a desktop and a laptop, right? Only, which you cannot use your mobiles, right? You have a web browser on desktop and laptop. Not technical experience required. Excellent. Pre-registration starts today, October 29th, one day before launch. Launch means that you're gonna be able to actually start mining nights. Allows you to pre-register your Cardano destination address so you can begin solving challenges as soon as the event opens on October 30th. So today you can register. Tomorrow, 00 UTC, you can start mining nights, right? Registration, you're gonna need a Cardano address. It's really easy. You have different wallets for you to do that. Eternal, Lace, Yoroi, etc. Right? We're gonna see on the dashboard that you have those options. Okay, so how do you participate? You're gonna have to follow this process. First, register. You're gonna go to this website. We're gonna go as well. I'm gonna show you the UI. You're gonna connect a verified Cardano wallet or manually enter your destination address, right? So creating a Cardano wallet is really easy. You don't need funds on that. Actually, you need to have a empty destination address, and then you're gonna have to sign. Let's follow the process here. Read and accept the token end user agreement. So you're gonna have to accept some legal conditions, commercial conditions, as always, right? This is just accepting the legal conditions based on your destination address. You are not exposing or disclosing any personal information at all. Then the sign process. Sign your unique claim message, which includes your destination address, a hash of the terms, and the acceptance statement. So it's a hash, right? What's gonna live on the blockchain. And this binds your address to your browser session, which your browser and your CPU is actually the one that is gonna be mining, right? And you're gonna send those solutions back to the server. So to actually start mining, then you have to start the process. So click start to begin processing solutions. The app runs while your device and browser remains active, right? So your browser needs to be open and the application running by clicking this start button, and you're gonna be mining. If you close your application or close your browser, then the mining process stops, right? I'm gonna show you the dashboard, the UI, that's gonna tell you everything about that process, and it's really intuitive to make sure to know that you're actually doing the right thing. There's gonna be some statuses that says, okay, if it's active, everything is okay in the process. For best results, let it run for the full 24-hour cycle each day. So the process as a whole is gonna last 21 days. It's gonna be divided in cycles of 24 hours, and within those 24 hours, challenges are gonna be sent every 1 hour, right? So and the snapshot takes place once per day. Okay, how tokens are allocated? About 626 million night tokens are available, split evenly across 21 days, and 30 million night per 24-hour cycle. So every cycle, 24 hours, there's a snapshot, and it's gonna be allocated approximately 30 million night. Okay, what else? Each cycle begins at 0 UTC and ends the next day. A snapshot is taken at the end of each cycle, 24 hours, and your allocation depends on how many cryptographic solutions you submit compared to the total submitted by all participants. So what's happening, right? This is a mining process. The server is gonna send some problem. People are gonna try to find the solutions, but it's not only you trying to solve something. There's a lot of people. As opposed to how other mining process works, this is not a competition. Everybody is gonna receive the same problem, and it can be solved by several people. The thing here is that depending on how many people got to solve that problem and send the solution, it's gonna relate to how much nights you're gonna receive, right? So if you solve like three problems and got the solutions, but as an overall, the whole world solve like 1 million of those problems and got the solutions, your allocation is gonna base on that ratio. Okay, what else? The event concludes on November 20th at 0 UTC. So perfect. Let's see the dashboard, and so you can better understand how this process is gonna flow and how you're gonna actually claim your tokens, connect your wallet, and stuff like that. So you have to go to this website, midnight.gd, and they just updated their UI. It looks really nice. It's clean, and you have here some frequent questions. So here you can see this is really nice questions and answers. I really recommend for you guys to go through these, and you're gonna have a better idea of how this process works in much deeper detail. Then you have some news. This is the blogs that we just read. Tokenomics. I really recommend reading this tokenomics white paper. You're gonna understand the relations and how it connects night with dust and other mechanics that is gonna take place within midnight. And then we have these three processes: glacier drop, that it already ended, and now we are going through the scavenger mine phase. So if I click here, you can see that it's going to started today, October 29th, and going all the way to November 19th. And this is kind of the UI is going to look like. We have these three processes that we mentioned. We first have to choose a destination address, then we have to accept the terms and sign, and then we're going to have to start the session, start the mining process. And here you can see on the dashboard that you're going to be able to see how many solutions you have submitted, what is your current challenge, how much time you have spent trying to solve a specific problem, challenge, and so on, how many nights have been allocated so far during this mining process. So all this information is going to be displayed during the mining process. You have this miner status as well, that if it's active, it means everything's okay on your machine. You are actually receiving challenges and you are actually mining. You are trying to solve that puzzle, right? So, well, this is open for everybody. You don't need to have a specific hardware or software or knowledge or being pre-qualified in some sense. This is just open for everybody. So I really recommend to go through this process. Thanks everyone for joining another Midnight session. It was great learning together. See you in the next episode. Bye bye.